continue our chapter 2. Chapter 2 is the derivative and the tangent line problem. Let's see, I have a function f of x here is a curve here. Alright, and I have 2 points, point A and point B. Point A is coordinate c, f of c, and point B is up here. Let's say the distance from here to here is delta x, from here to here is delta y. So basically, the B coordinate, the x change by delta x. So c plus delta x. And the y coordinate also change by f of c plus delta x. Now as the point A and B get closer and closer together, which means your delta x is become 0, you're gonna end up here at this point, and this is the tangent line. So the slope of the tangent line to the graph of f at point C, f of c, is also called the slope of the graph of f at x equal to c. Now if you remember definition of slope, the slope is the change of y minus over change of x. So if you call this y2 and y1, so just y2 minus y1, x2 minus x1, the c will cancel out, you just left with delta x. Alright, so let's look at our first example. The first example, they want you to find slope. F of x is equal to 2x minus 3. This is linear. The slope is y equal mx plus b. The slope is 2. And linear, the line slope is constant. But instead of use the formula of slope, I'm going to use this one instead. So I'm going to do limit as delta x go to 0. I'm using this one here, and my c here is 2. Alright, my c here is 2. So f of x is 2x minus 3. You have to do f of 2. Let me write it here. F of 2 plus delta x, because this c is 2. So you're gonna have 2 is this 2. Instead of x, you replace by 2 plus delta x minus 3. That would be your f of 2 plus delta x. Your f of c here will be f of 2, which is, replace 2 here, it will be 2 times 2 minus 3. Alright, so I'm going to put this in formula here. So you're going to have f of 2 plus delta x, which is that one I just did. 2 plus delta x minus 3 minus f of 2. F of 2 here is just 2 times 2 minus 3 over delta x. Alright, this is just my scratch paper. Alright, so from here, let's continue. I have limit as x approach, delta x approaching 0. Let's distribute everything in. I would have 4 plus 2 delta x minus 3 minus 4 plus 3 over delta x. Plus 3 minus 3 cancel, plus 4 minus 4 cancel. So you left with this 2 delta x because I ran out of room. The delta x and delta x can cancel out, so limit would equal to 2. Limit as delta x equal to 0 equal to 2. It's like what we expect is going to be 2. Now this is a linear. Slope will be constant. If you have different shape, slope will be different at different point. Basically, slope is derivative. So this is derivative. and this is parabola, right? This is the parabola. So it's going to be parabola open upward. At different point, slope are different. So the definition of derivative, all right, is very similar to this one, all right? So I'm just gonna erase this, okay, and change it to definition of derivative. This is derivative of a function f of x equal to limit as delta x go to 0. Now we don't have a constant c. In this case, our constant is 2. We have a variable at different point. Your x is different. So instead of c, I'm gonna call it x. Let me write better. Actually, it's the same formula, but because the c change and it's different slope at different point. All right, so that is the formula for derivative right here. And the procedure is the same thing. All right, we're gonna do this. The procedure is the same thing. So we're gonna take limit as delta x approaching 0, follow the definition, f of x plus delta x. So instead of f of x, I'm gonna have f of x plus delta x. So I'm gonna have x plus delta x squared, because I'm gonna replace all the x with x plus delta x. So it's gonna be x plus delta x squared plus x plus delta x, replace x by x plus delta x minus 3. This is just my first function over here, right? My second function is just minus f of x, which is this one. Divide by delta x. Alright. Next step I'm gonna simplify this. So I'm gonna have limit as delta x approaching 0. This is a perfect square. So first term square plus twice first time last plus last square. Right? I expand this. First term square plus twice first time last square plus x plus delta x minus 3. This is just from the first one right here. And this one, I'm going to distribute the minus in. So I have minus x squared minus x plus 3 over delta x. Alright, next step I'm gonna simplify. I can reduce x squared plus x minus x plus 3 minus 3. I think that's about it. Alright, so I'm gonna left with limit delta x approaching 0, 2x delta x plus delta x quantity square plus delta x over delta x. Alright, next step I'm going to factor out delta x. So I'm going to have limit as delta x approaching 0, factor out delta x. So I'm going to left with 2x plus delta x plus 1 over delta x. Alright, cancel delta x. I'm gonna left with limit as delta x approaching 0, 2x plus delta x plus 1. Now I can do direct substitution. As delta x approaching 0, I'm gonna have the slope is 2x plus 1, or the derivative is 2x plus 1. So at different x, you would have different derivative. When x equal to 1, you're going to have 3. When x equal to 2, you're going to have 5. All right? See you next section.